All right. I think we're going to go ahead and get started. I want to welcome everybody. I'm Andy Rich. I'm the Dean of the Colin Powell School, which is the School of Social Sciences here at City College. And I want to welcome you to a conversation about reducing the impacts of climate change while advancing environmental justice. We are very pleased to have Radley Horton with us today. And it is wonderful to have a great audience. We don't usually do events in the middle of the summer, and we weren't really sure what to expect. But this is not a normal summer, so we wanted to give it a try, and I'm grateful that so many of you could be with us for this conversation. So climate change and sustainability, environmental justice are priority issues for the Colin Powell School and across City College. They are among the most important challenges we face globally. And here at City College, we're in the midst of what we have called the Year of Sustainability. It's been a special year that is creating opportunities for new interdisciplinary collaborations and new programs that are important for the campus and for New York City. Collaborations and programs that we hope will grow over the next decade. One important contribution to that effort has been the creation of a new program out of the Colin Powell School called Climate Policy Fellows. This is a program that is led by Trevor Hauser, an alum of City College and an international leader on climate policy. And the Climate Policy Fellows program is an initiative aimed at diversifying the ranks of leaders in the climate policy space. We support equal numbers of engineering, architecture, science, and social science students. They get rigorous training, they get paid summer internships. It's all with an eye to putting them on track to careers as climate policy leaders. And our second cohort of Climate Policy Fellows was just selected after what was one of our most competitive and our most selective recruitment processes really that we've ever had. Most of them are here with us today, and I want to congratulate them. We look forward to their questions today and to their involvement with us over the next year. One of our core supporters and partners on the Climate Policy Fellows program is Turner Construction. They are a leader internationally on sustainability. They are supporting our program financially. They are providing mentorship and guidance to our fellows, and they are offering internships and jobs. And they are the reason why we have Radley Horton speaking to us today. Professor Horton is the Lamont Associate Research Professor at the Lamont-Doherty Earth Observatory at Columbia University. His research focuses on climate extremes, climate impacts, and adaptation. He was a convening lead author for the third National Climate Assessment. He is the lead principal investigator for the NOAA Regional Integrated Sciences and Assessments Funded Consortium for Climate Risk in the Urban Northeast. And he has served as the climate science lead for the New York City panel on climate change. In my very first conversation about the Climate Policy Fellows with Peter Davorin, the CEO of Turner, who's with us here today, this was a conversation we had, I think now almost a year ago. He said, let's get Radley Horton involved. And so that is exactly what we have done. And I want to offer my sincere thanks to Peter and to Turner, and my thanks to Radley for joining us today. So Radley is going to share remarks for the first half, about 45, 50 minutes of the session, and then we'll have time for a Q&A. And my colleague, Debbie Chang, who is our Director of Fellowships and Public Service Partnerships, and she's also the other lead person for our Climate Policy Fellows program. She's going to moderate the Q&A, so as you have questions during Radley's presentations, go ahead and share them with us in the chat space, and Debbie will then pull your questions from there. Last note, we are recording the conversation so that those who are not able to be with us right now can view it later, and we have muted everybody. So with that, Radley, let me turn it over to you. Thanks again for being with us today.
Great, thank you, Andy. Thanks, Debbie and Peter, too. I'm thrilled to have the chance to really have a dialogue with you all today. What I really want to highlight in this talk, there's sort of two main takeaways. I hope folks coming out of this talk will have a sense that climate change really is going to touch on any particular passion of yours, any field, any area of endeavor that you might want to pursue in your career. And there's going to be a way for it to intersect with these climate issues that are going to be so critical and that touch on everything. So I hope we have a chance to talk about some of the different ways that no matter what your interest is, whether it's social science, whether it's visual art, architecture, you name it, or physical sciences, there's a path to engage in dialogues around climate issues. And the second point, a related point, is all the ways that climate intersects with environmental justice issues. I think this is something that's on everybody's minds these days, and we'll have a lot of time to talk about that. I should note that my lens, my bias in a sense, if you will, is what's sometimes referred to as like a top-down approach to thinking about hazards and solutions. The kind of technical expert, in my case as a climate scientist, who's trying to give suggestions for how we can become more resilient, how can we can become less vulnerable to hazards. I think that's an important perspective to have, again, this sort of expert-based approach. But it's clearly not enough. We simultaneously, to be resilient, need what's sometimes referred to as more bottom-up approaches that don't necessarily start from saying, for example, in thinking about climate change, how is rainfall going to change, or sea level rise? How are we going to prepare for those things? But an approach that sort of inverts and starts from a baseline in communities, asking, what are people in communities concerned about? What are some of the legacies of racism, environmental injustice, that provide a lens for thinking about all issues, including climate change? So they're not totally different perspectives. I think the point I'll try to make is that we need an intersection of people from all different backgrounds, all different interests. The sort of unfortunately named top-down experts have a central role, but also the bottom-up roles within the communities as we think about environmental justice issues and the right-sized solutions for different communities. It's this dialogue, this interface with huge policy implications that I think is so exciting. And because climate touches everything, for better or worse, it gives us so many connection points for thinking about the future world that we want to have. So with that, I'll just give sort of a quick overview here of the material that we're going to cover. I'll start with the basics of climate science. I'm starting from the assumption that folks have a general sense that increasing greenhouse gas emissions due to human activities are changing a lot of risks, but we'll go into some details about that. And I know several of you are going to have the chance to participate in Al Gore's climate training in coming weeks to get into more detail on some of those issues. Then we'll talk specifically about extreme weather events, how they're connected to the story about climate change, how communities are especially vulnerable to those extreme events, whether it's the heat waves or the storm surge coastal flooding events, the fires and droughts. So we'll talk about how those extreme events are changing and how they impact society. Then we'll talk a little bit about some sort of frontier aspects of climate science, things like tipping points that we worry about, of how the climate could change very dramatically if we're not careful and don't reduce our emissions dramatically. That'll lead us to talk briefly about different solutions. How as a society we can reduce our emissions? How as a society we can become more resilient to be better prepared for some of the climate changes that are coming? And I'll focus especially on some examples of this science policy interaction within New York City and state, because I gather that's an interest of many of you. So I'll have some reflections on that. And then I do want to sort of bring back at the end and emphasize some of these connections to environmental justice issues that'll come up throughout the talk. And also to COVID-19, which again is that sort of same interface in a lot of ways. Because if we say which communities are most vulnerable to extreme weather events, a lot of times it ends up being the same communities that are most vulnerable to COVID-19. And we'll see that that's not entirely a coincidence. A couple other just sort of takeaways. These will be the sort of points that are made during the talk on the climate science side. Extreme events have already changed dramatically in their frequency and intensity. We're already in a different world than a lot of, for example, our critical infrastructure, our agricultural systems are adapted to. So there are major changes coming with further climate change. And there are non-linearities in terms of how agricultural systems, cities, individuals' human health are going to be impacted by those changes. So as temperatures get a little higher, just a little more warming has a much bigger effect than it had back when temperatures were lower because of these nonlinear impacts. And if we keep increasing our greenhouse gas emissions dramatically, all bets are off in some ways. If we push too far, we literally can unleash powerful feedbacks that are very hard for us to predict with things like climate models and impact models. So we open the door to very negative outcomes that could be hard to adapt to. So all the more reason to not emit a lot of greenhouse gases. But fortunately, just as there are these dangerous climate tipping points that we have to avoid, there are positive outcomes in terms of tipping points too. We are seeing huge innovations in terms of reducing greenhouse gas emissions, becoming more resilient. And those too could lead to disruptive, in a positive sense, opportunities. And I think a rapid transformation in society towards a more just world, a world with much fewer climate emissions, and a more resilient world for all. Okay, so jumping into the first part here, the climate science overview. We'll go through this fairly quickly, but just to show how dramatically the world has already changed. These are air temperatures, essentially at the Earth's surface, where you're, through time, you see the animation is showing us we're now in the 1950s, 60s, 70s. With each decade, you see more of these yellow, orange, and red colors. That means temperatures that are warmer during that 5-year period than this long-term average from 1950 to 1980. So if we run that again, we can see that the statistics have already shifted. In any 5-year period, some places are warm, some are cool, but with the passage of time, the statistics start to shift. Almost everywhere is warm, and some places become exceptionally warm. So this is how the world has already changed. And everything you see here is just due to about 1 degree Celsius, 2 degrees Fahrenheit of global warming, which doesn't sound like much, but as we'll see, is a huge deal. We can also, instead of looking at these animations through time, just look at the long-term trend. Look at 112 years of data, again, for surface temperatures. And what you see here is almost the entire globe has warmed. Places where you see the purple color, those are areas that have warmed 2.5 degrees Celsius, about 4 degrees Fahrenheit, just in the last 110 years or so. Areas in white have no data, especially for the early part of the 20th century, so we can't calculate a trend. The only places that have had a downward trend in temperature are those little blue areas that you see south of Greenland in the North Atlantic, and a couple spots in the southeastern United States. And those negative temperature changes are about an order of magnitude smaller than the biggest warming. So where some places have warmed about 4 degrees Fahrenheit, the most cooling we've seen is like 0.5 degree. So again, the statistics have shifted. It's not just temperature that's going up though. We're also seeing across a range of climate variables, major shifts. The oceans are warming, causing damages to coral reefs. We're seeing melting of the land-based ice sheets and mountain glaciers, pushing more water into the ocean, causing sea levels to rise. As the atmosphere warms, as the ocean warms, water's evaporating, and the warmer atmosphere can hold more moisture. We're going to talk about how that's leading, paradoxically, to more heavy rain events, more dangerous flooding that damages our critical infrastructure and our water bodies through pollution. But in addition to more rain in some places, you're also seeing more drought and more fire because of more evaporation, because that warmer atmosphere can hold more moisture. It's pulling more moisture out of our soil, out of our crops, out of our trees. So basically leading to more of many types of extremes. So it's not just temperature. How can we start to link this change in the climate to human activities? Well, the first thing to do is look at concentrations of greenhouse gases like carbon dioxide. Over a time scale of 800,000 years shown here, it's actually similar if we go back about 3 million years. Greenhouse gas concentration stayed in this narrow range of about 180 to 300, 280 really parts per million until the Industrial Revolution. right around the 18th century, we started to see an increase. And by the time we got to the present, we have more than 40% more greenhouse gases in the atmosphere, carbon dioxide specifically, than we did just 250 years ago. We can look at the chemical composition of that carbon dioxide and say definitively that this is fossilized carbon. This is coal, natural gas, basically ancient carbon. And by looking at that chemical signature, we can see that it's our activities, it's the burning of those fossil fuels that's the primary mover for these increases. The basic physics can connect us so that these aren't just two parallel but potentially unrelated phenomenon, right? Because we could say, all right, it's warming, all right, carbon dioxide concentrations are going up. That's just a correlation. How do we know that there's causation and a relationship between these things? Well, one of the reasons, simple physics that have been understood for well over 100, 200 years. Basically, we know that the atmosphere is essentially a blanket, and it's a one-way blanket in a sense. Carbon dioxide, as we put more of it in the atmosphere, is very effective at blocking the Earth's attempt to re-radiate heat back out to space. The wavelength of that radiation being reflected from the Earth, which is long wave, not particularly intense, just happens to be just right for the carbon dioxide in the atmosphere and other greenhouse gases to scatter, absorb, reflect it, sending some of that heat back down to the surface, causing more warming. I called it a one-way blanket because those greenhouse gases do not have a similar effect on high-intensity solar radiation or shortwave. It's easily penetrated. So basically this blanket just prevents the Earth from re-radiating heat. And again, those physics have been well understood for a very long time. I don't want to go into the details of, given the time of the critical discoveries that were made, but you can see some of them go back really to the 18th century. I also wanted to put this up to note all white males, right? This is something that we need to think about as we're thinking about the history in the sciences. Diversity in earth science is getting a little better in the last couple decades, if we're talking especially about gender balance. But there remain huge issues in terms of underrepresented minorities. And I think maybe in our question and answer, I think it'd be great to get into some of the issues about how within physical sciences, but also across other disciplines, we can work to change this. Because if only a small segment of society is making these scientific discoveries, we're not going to make the same kind of advances. We're missing so much of the talent pool, separate from the issues of equity and justice, of everyone deserving to have the chance to follow their passion, whether it's earth science or something else. Okay, so now back to our linkages between increasing greenhouse gas concentrations due to human activity on the one hand, and the temperature changes that we're observing on the other. So a critical additional line of evidence separate from physical understanding and just observing these variables moving in the same direction, both increasing. An additional factor comes when we look at results from climate models. So this is a really important graphic, so I do want to spend a little bit of time on it. When you look at the black line, what you're seeing there is going back to 1900, what were global temperatures, averaged across the whole globe. And the y-axis is just showing it as a sort of departure from a long-term average. So when it's below zero, that was a period that was cooler than normal. And then you see the numbers rising as we get towards the end, towards early in the 21st century. So that's the observed warming trend. But what's really important to focus on is those two banded colors. Let's talk first about that olive light green color. That's showing you results we get when we use a climate model, which is our best effort to capture all the physical processes in the climate system, right? The clouds, transfer of momentum in the atmosphere and in the ocean, interactions between the land and the ocean and the air. When we run those models in a historical way, so we're starting them with the greenhouse gas concentrations that we actually had in the atmosphere in 1900, about 35% lower than they were today. The olive line shows you the temperatures we get if we start the models back then with the greenhouse gas concentrations they had then, and then just move the model forward, holding the greenhouse gas concentrations constant. So we'd allow in those models volcanoes to take place when they actually took place. So the years we had big eruptions that cooled the planet a little bit, we include that in the model. We also include things like sunspot cycles that have been proposed as an alternate hypothesis to explain warming. Those climate model simulations in the light green, you can see here, they don't capture well what we actually observed over the 20th century and into the 21st. But when we run those identical climate models with just one change, starting them in 1900, but now, again, with the greenhouse gas concentrations of 1900, but in this case, allowing the concentrations to go up each year to match what we actually observed. Still keeping the sunspots and the volcanoes, but now also with the greenhouse gases due to human activities. That is the blue band that you see there. A much better predictor, based on the past, of what we actually observed. So this kind of work using models lets us test different hypotheses. We've really only had one Earth simulation, right, of actual sort of observation. So it's hard to unpack different causes or drivers. But by changing things in climate models and running them over a historical period, we can test different hypotheses. And what you see from this graph is you need to include the human activities and the fossil fuels to explain where we've gone, where in the last 100 years, and that's our best tool for predicting where we're going to go in the future. Okay, so now let's pivot towards the extreme events discussion. And it seems, unfortunately, that I'm having an issue with this graphic here. Okay, that's unfortunate. Okay, so I'll just talk about what you should have seen here, unfortunately. This would basically be what you think of as a bell curve, a kind of histogram, where on the vertical axis, you see frequency of occurrence of days of a certain temperature. And then on the y-axis, you'd be seeing what those actual temperatures were. So really cold days are pretty rare, there are low heights, but then you get into the heart of the bell curve, temperatures of 50 or 60 degrees in New York that are, very common, often occur. But then as we get out into the tail, 100-degree or so days, those are also very, very rare. Now with climate change, if we just shift those statistics a little bit, if every day warms by about 2 degrees, the bell curve shifts a little bit to the right. You end up seeing, as that curve shifts, almost no change in your hottest days per year, but a big change in the frequency of really, really hot days, and a big change in the magnitude of just how hot it can get. And that's really important because people are much more vulnerable when temperatures get really high. Air conditioning and the electric grid experience much stronger demands and are more likely to fail as temperatures get really high. A lot of critical materials, roads, for example, and home design, vulnerable to very high temperatures. So that was just, and again, I apologize for that not being visible. That was sort of a hypothetical schematic, but we can actually look at real data and observe that with that 2 degrees Fahrenheit of warming that we saw earlier, we're already seeing this shift towards a lot more hot days and a lot fewer cold days. So the graph on your left is showing you the ratio in a given year of how often you had record-breaking high temperatures versus record-breaking low temperatures across 1,800 different weather stations in the US. And you can see for a lot of the 20th century in an individual year, as shown in the blue color, you had maybe more record-breaking cool than record-breaking high temperatures. But something shifted dramatically, roughly 20 years or so ago. We got into this mode where almost every year, average across 1,800 stations, had far more days where a record high was reported than you had days where a record low was reported. And look at a few individual years early in the 2010s where we had 7 times as many record-breaking highs as record-breaking lows. So there's this non-linear relationship where a little bit of warming can give you far more of these extreme events that we're so vulnerable to. You can still, even across the whole US, have a year, as we saw in 2013 and 2014, with more record-breaking lows than record-breaking highs. There's still some natural variability in the system, but the statistics have already shifted. If you're a planner, if you're someone thinking about public health and climate change, if you're thinking about the effects of sea level rise, you can no longer plan for the climate of the past. The statistics have already shifted. The more we increase greenhouse gases, the more quickly these statistics are going to shift. And then the map is showing you a projection out into the future, not far into the future, just really a generation from now, about 30 years, and how much more often we expect to see 90-degree days in a given year in the future if we keep emitting greenhouse gases at a high level relative to today. And that particular arrow is pointing towards, roughly pointing towards Kansas City. If we compare a baseline climate period, a recent 30 years, Kansas City averaged about 40 days a year where temperatures got above 90. And just within the next generation, that's going to more than double, right? So this is, a huge burden on people, on infrastructure, on ecosystems, on agriculture, on air conditioning demand that we're, still not fully prepared for. Apologize, I'm having some issues here with my graphics. There we go. Okay, so to make the same point now with sea level rise, again, small amount of sea level rise means a huge change in coastal flooding. We have had about a foot of sea level rise in the last century, actually a little bit less. It doesn't sound like much, but we're having far more frequent coastal flooding. And as we look out to the future, there are big uncertainties about how much sea level rise we're going to get. It's going to depend on how much ice melts, especially on land. But I'm going to show you that even under a best case scenario, if we have 1 to 2 feet of additional sea level rise this century, which as you can see is about the best we can hope for, the impacts on our coastal communities are going to be huge. On the left here, you're seeing how over the past 2 generations, the frequency of coastal flooding, nuisance events, has increased. So the vertical axis, which is also the colors, showing you across a whole bunch of coastal locations in the US, including New York, these events that back in 1950 only happened a few times per year, maybe a unusually high astronomical tide, now are happening once a week in some places. These aren't storms. This is just the gradual effect of sea level getting higher, raising the baseline, raising the floor. So these minor, what used to be minor flood events are actually now having noticeable impacts. People are having water in their basements. They can't open their businesses. They can't travel home along their main coastal route. There's a lot of concern about at what point society is going to realize that this risk is only going to grow. It's not currently priced, for example, into a lot of markets. It's not something that bond underwriters are necessarily thinking a lot about, and they're thinking about viability of future infrastructure investments, for example, but this could shift very rapidly as societal perception of these risks changes. And looking towards the future in the map at the right, this is showing you a future that, as I just mentioned, with very little sea level rise. If we only had 1 to 2 feet of sea level rise, our best case scenario, and if we just got the storms of the past, if hurricanes didn't get any stronger, nor'easters didn't get any stronger, this map is showing you will have severe coastal flooding, that 1 in 100-year high water level event, which is devastating. That's the Hurricane Sandy storm surge, becoming far more common. Each of these places, whatever used to happen once every 100 years, that high water threshold becomes something that happens within the lifetime of a typical home mortgage in many places. And in some places in Southern California, near Port of Long Beach, parts of the Atlantic southern coast, every year or two, you could get those high water levels that people think of as a 1 in 100-year event that helps determine whether you can get insurance, whether you can get zoning. So, and obviously with huge implications for loss of life. Just to quickly note, I said earlier, it's also heavy rain and drought that are changing. Here you can see historical trends in heavy rain events. The northeastern US, the rainiest day per year now has about 55% more rain in it. It's that much wetter than it used to be just a couple generations ago. So it's no coincidence that a lot of our storm sewer systems, our road networks, our drainage systems are overtaxed. Partly it's a story about not having invested enough in our infrastructure, but certainly a big part of the story, climate change as well. And then the other side of the coin, other areas becoming drier and having more fire risk. In some places, it might paradoxically not even mean that it's actually raining less than it used to. It might just be that as the atmosphere is warming up, it's able to hold a lot more moisture. You warm the atmosphere 1 degree, and it can hold 1 degree Celsius, it can hold 7% more moisture. So even if your rainfall stayed the same, once you start to have 2 degrees of warming, the atmosphere can hold 14% more moisture than it could before. All of your crops, all of your plants, all your soil are going to be giving up more of their moisture to the atmosphere, leading to more of these severe fires. And as shown in this animation using a climate model from NASA, a tendency in this one climate model only towards essentially almost like perpetual drought conditions, as defined by soil moisture anyway, by the time we get to late in the century. Okay, let's talk a little bit more about some of the specific impacts. So this is an important graph from the IPCC that's basically shown, the Intergovernmental Panel on Climate Change, that's giving a sense of how different critical systems are vulnerable to increasing temperatures. The y-axis is showing you an amount of warming. We've already had, this is in degrees Celsius, we've already had that 1 degree Celsius, approximately 2 degrees Fahrenheit of global warming as shown through the gray bar. And as we'll see, we're probably already locked in to an additional 0.5 degree Celsius of warming. And if we're not careful, if we don't dramatically reduce our emissions, we're even going to blow through that 2 degrees Celsius warming target shown higher up on the graph. So what are the colors showing you? The colors are showing you for each of these systems how vulnerable they are to a certain amount of warming. So if we look at the coral reefs, right, one of the bases of the marine food chain, a huge source of biodiversity, critical for a lot of tourism-dependent economies. Already, with 1 degree Celsius of warming, they're starting to flash purple, which essentially means very high risk that this system is already crossing thresholds that we can't adapt to, where we could just see irreversible, huge changes and potentially even collapse of these systems. So this is a huge and underreported issue, right? It's not just the coral reefs. We can see similar things if we look at the Arctic region, where we're losing sea ice really rapidly. People might say, who cares about sea ice? But sea ice, in addition to the critical sort of ecosystems in the polar regions, is kind of the freezer of the world in a way. When we have that Arctic sea ice, which is melting fast, when it's present, sunlight is reflected very well off that white surface. The heat goes back to space. When the ice melts and we have an ocean surface underneath, which is a very dark surface, very good at absorbing sunlight, you get warming, which warming of that water then makes the ice nearby melt even faster in a feedback cycle. So we're very concerned about that. I'm going to talk just briefly a bit about this heat-related morbidity and mortality, which is something we're also very concerned about and doing some research on. So some folks might have seen, we can send this around, a paper we had out last month that looked at lethal combinations of not just temperature, but also humidity, right? So the cliche that it's not just the heat, it's the humidity. And what we've been looking at in our studies is that more and more parts of the world, including a lot of places that historically have contributed very little greenhouse gases, that haven't been responsible for much fossil fuel burning, are starting to cross thresholds where they're getting combinations of temperature and humidity that are so extreme, so oppressive, that you almost can't survive outdoors. Certainly you can't do outdoor labor unless you're protected. So we're thinking about farmers in South Asia. We're thinking about people working in the coastal regions of the Persian Gulf, but also parts of the US, right? Where we have kids doing sports outdoors. When it's really hot and really humid, those activities can't continue. And our communities with extreme health concerns, pre-existing health conditions, no access to air conditioning are particularly vulnerable. So this plot is showing how for any spot in the world, there's a typical sort of worst day per year of heat and humidity. This is when we think of like the dew point index or the heat index. These capture that combination of heat and humidity. And what you're seeing here is 2 generations from now, if we keep emitting greenhouse gases the way we have been, how many days per year in each of these cities is going to be as hot and humid as the worst day per year is today. And this graph is in months. So you can see large parts of the tropics experiencing potentially 1 out of every 2 days during the year being as hot and humid as the worst day per year currently is. This is another one of these like really unappreciated risks. There's so many vulnerable communities, and we haven't done enough work on how to protect people who don't have access to air conditioning. There's some very exciting work being done, including Turner's leading in a lot of this work on vulnerable outdoor laborers in the construction industry, for example. We need more work to connect some of these lessons for example, some communities, outdoor farmers to see what they can do to be safer. Okay, a very quick pivot through some hot topics specifically in climate science that I think are going to be important from a risk perspective to think about. Compound extreme events. We can't just think about an individual event in isolation, right? It's not enough for New York City to say, what if we get a heat wave, or what if we get a hurricane? It's necessary to also say, what if we get a heat wave after a hurricane has just knocked the power out, as one example. Tipping points and tail risks. I gave the example of Arctic sea ice. We'll talk a little more about that. And I think, this issue of cascading impacts, how do we prepare for all the ways we can be affected by a climate hazard? Those of us who remember Sandy, one of the big takeaways was that there are all these indirect ways that we could be affected. An individual, infrastructure sector, whether it was the electric system or transportation, needed to think about their interdependencies with each other, not just how the systems they own themselves would be affected. COVID-19, I think, is also giving us a ton of lessons now about indirect impacts and the challenges of trying to predict all the ways we can be affected. We need to think about resilient strategies that help make communities stronger, no matter what happens, whether there's an extreme event or not. I'll briefly mention some work on legal aspects of attributing extreme events to fossil fuel emitters. We're starting to see a wave of lawsuits against major emitters of fossil fuels, saying that they're responsible for some portion of the damages. Cities, including New York, have been involved in some of these suits, seeking damages. There's going to be more of that in the future. And there's a lot of work now on retreating from vulnerable areas that we'll talk about as well. So one example of a compound extreme event here in 2017, we had 3 extremely powerful hurricanes barreling towards the Caribbean and the Eastern US. Do reinsurers think about the risk of several extreme events in a year? Do our capacities, is our federal government capable of dealing with multiple disasters? What if we have one big hurricane, one big fire season in the same year? Are we going to break the bank at some point in terms of either our financial resources, our insurance funds at federal or private or state levels, but also in terms of our emergency response, being able to address these issues? Tipping points in the climate system, I already referred to the loss of Arctic sea ice, coral reefs. Just to quickly note that there are a lot of systems that we're worried about. We're watching Siberia, so hot this past month, as some of you have probably heard. To what extent is that going to actually heat up the frozen ground that contains ancient permafrost of carbon and methane, causing a feedback with more warming? These are all things that we're concerned about. The cascading impacts, having another issue with the graphic here. I think in the interest of time, I'll move forward anyway. But systems are very, very connected, as I mentioned in the Sandy example. So to bring up this point that, this focus on climate goes so far beyond the physical science. One experience I've had in recent years is partnering with legal scholars, and including at my university at Columbia, to look at this interface where science advances that are enabling us, when an extreme event like Hurricane Harvey happens, to run those climate models that I showed earlier in the historical setting with increasing greenhouse gases or staying constant levels. If we see events happening more often when we increase the greenhouse gases, we can attribute some portion of the added frequency of those events, and maybe even the damages that were experienced during the events, losses due to flooding, for example, to historical emissions, then the next step that some people are pursuing is to say, all right, well, which nations, which sectors of the economy have been responsible for those emissions in the past? Should they be held accountable for a fractional percentage of the damages? So it's not clear, how successful some of these lawsuits are going to be, but there is an absolute tidal wave of these lawsuits happening, and it's posing, I think, additional reputational risks, potential financial risks that you're going to hear more and more about. So this is another headwind that the fossil fuel companies especially are facing. And I brought it up also to just show how legal scholars, for example, are engaging in climate issues right now. Another hot topic we're spending a lot of time on is this notion of managed retreat. That as we see more fires, for example, in the Western US, as we see more parts of the world crossing these humid heat thresholds, as we see higher temperatures and drought making basic agricultural livelihood more challenging for people, as we see sea levels rising, is there going to be a point where some places start to say, we can't afford to try to adapt in place? We're in South Florida. We can't build a seawall because there's limestone underneath and the water will just percolate up. If we can't build that seawall, and if our vulnerability is going up also to more frequent hurricanes with high water, at what point do we start to have the conversation about moving out of those areas? Who decides who moves? Where do people move to? Who pays? What's the role of the law? What's the role of environmental justice? Who decides who should move? Do communities get to decide themselves? Who has access to the information about sea levels rising first? Who first gets the word that the property values might drop? There are all sorts of environmental justice dimensions to this. One of the really interesting ones, it's sort of circling back to my initial slide, when we convene this major conference on this topic, there's this perspective that I have as the sort of climate science expert. We have to sort of remain humble. There's a tendency to walk into a room and say, we know this is what's going to happen to sea level rise here. We know it's not going to be viable to stay in this area. But one of the big takeaways from the conference, and working with communities that have historically experienced a lot of racism, redlining, for example, and in the past have had experts maybe, telling them what they have to do. There's pushback, and now communities want to have more control over the dialogue. They want to be able to pose the questions themselves rather than having the experts just tell them. And I think, the best position is somewhere in the middle, where communities are able to think about the particular context that works for them and have access to information, but still in a way that connects with the science in the sense of what might be possible, for example, from an engineering perspective. But as we think about these challenging topics like managed retreat, which communities are the most vulnerable, we need to also be thinking about how communities can engage and lead some of these dialogues, because environmental justice issues are central to these questions. We're going to reconvene this conference in a year, and we're going to change.
Well, did we lose Radley? We lost Radley. Okay.
We did.
Well, that's a first for me. And no, he's back. I see him over here.
I apologize for that. Was the connection unstable for a while before that, or did it just go all of a sudden?
Just all of a sudden, I think. So,
okay,
yeah.
Well, that's good. We'll take
it picked right up where you left off.
Okay, I apologize for that.
Lockout at reconvening the conference.
Yes. Okay, perfect. Thank you. So when we reconvene this, everyone can hear me okay, right? Good.
Yeah.
So when we reconvene, we are going to be having these environmental justice issues in the title and be a central part of the planet. Okay, now talking a little bit more about specific solutions. This is not, fortunately, there are things we can do about all these problems. We can reduce our emissions. We can become more resilient through building strategies. We can help communities become more resilient in a variety of ways as well. So as we get to that discussion of how to reduce emissions, I want to circle back and reference, as you saw earlier, we've had 1 degree Celsius of warming. We're probably locked into 1.5 degrees Celsius, and we could see 2 degrees Celsius very easily. We're going to have a little reality check to show sort of where we are societally in terms of our emissions shown on the y-axis. This is essentially the amount of greenhouse gas emissions each year. So the baseline, essentially business as usual, is shown in red. If we start thinking about pledges that were made, for example, at Paris a few years ago, these nationally determined contributions to reduce emissions, you can see that shown in the blue colors, let's say. So, and I should note that several countries, including the US, haven't committed to honoring those Paris pledges. But even if the pledges were honored, you'd see it would knock these emissions trajectories down a little bit, as shown in those 2 blue colors, but there'd be a major gap. And if we want to get onto this 2 degrees Celsius scenario where we avert the worst impacts, you can see we need to bend that curve of emissions down dramatically starting in this decade. And it continues strongly thereafter, as you can see. And to get to that 1.5 degree target, it's a more stark, to say the least, reduction. But I'm going to make the case doable, and that we essentially have to believe that this is doable. That's the sort of first step towards actually making it happen. And there's a lot of reason for optimism, even though change has been slow, as we'll see. So when we're thinking about solutions, the first thing is to acknowledge that there is a pathway towards essentially doing nothing, right? Some people have argued that it'll be too costly for the economy. Climate change isn't a real threat. Maybe we don't reduce our emissions. Maybe we don't ramp up and become much more ambitious in protecting our vulnerable communities through adaptation. Other approaches that I'll emphasize here are major decarbonization of society. I'll point to the example of how New York State, which sort of on its own is one of the world's largest economies. I think roughly 10th in the world if it was a nation. Maybe a little lower, but certainly top 20, show what they're pledging to do and how they're going to do it. And then we need to mainstream our adaptation strategies, whether it's in situ adaptation, things like building flood walls, things like helping our buildings passively be able to hold water in the bottom floors, for example, moving critical equipment like generators to upper floors. There are things that we can do. I think in the interest of time, we won't get into geoengineering here, but happy to talk about that in the Q&A. Okay, so a quick run through some New York City examples to give a sense of what's actually happening. So, I wanted to reflect a little bit on the policy component and some of my interactions as a scientist. So I have had the chance to work with the New York City panel on climate change. I'm actually going to be involved in this coming iteration that's coming up too. This is a panel of experts, not just in climate science, that's critical. So people focused on social science and vulnerability, health of communities, risk management experts, just to name a few. This New York City panel on climate change was first convened under Mayor Michael Bloomberg in 2008. It was very ambitious, really showed leadership in adaptation for sort of one of the first times by a major city. And the early iterations, I would say, were very infrastructure focused and sort of technocratic in their focus. So they were very successful, but they didn't necessarily in the first iteration sort of explicitly have a big focus on environmental justice issues, public health issues, access to parks, things like that were not necessary, and ecosystem services in general, in early iterations were not so much of a focus. That has really shifted under Mayor de Blasio, and I think in future iterations is likely to continue to shift. And the work of this panel providing scientific, broadly defined scientific advice to the city was codified in the local law. I think that's important. You know, it's not just these reports that come out that can be of use. You know, when you can actually kind of change the laws, and there are equivalent laws. There's a CRRA law some folks might be familiar with at the state level, related to certain amounts of sea level rise you have to plan for. Once these things get into law, these recommendations can have a really big impact. And there's critical roles for the private sector too that we might be able to discuss later. So, quick example of sort of how this science works. For the 2015 iteration of this NPCC, the New York City Panel on Climate Change, you can see an example here of how some flood mapping shows how different facilities may be underwater at times in the future. Useful information as we're thinking about things like insurance, things like where seawalls can be built, and potentially how some facilities might need to be moved. So one of the ways that the science can interact is certainly with the engineers, with the architects and the planners, those designing resilient facilities. And it can't just be a one-way handoff, right, from the physical scientists. It needs to be a discussion from the beginning with the experts, with the builders, with the people at New York City DEP, with the people in NGOs working on ecosystem services. What are the climate hazards that are the biggest threats to those entities right now? Is it heat waves? Is it heat and humidity? Is there a particular temperature threshold that matters the most? What is the time scale of investments towards resilience? Have that dialogue, that communication, those workshops from the beginning. That's how you build the powerful partnerships, and it's critical to do that in all communities. This is a schematic developed with New York City to show how, by doing both emissions reductions and resilient adaptation strategies in a flexible way, where we, for example, plan to build a seawall with a wide base so that as we get future information about how much sea level is going to rise, because there are uncertainties, or how much people might be moving into vulnerable areas, we can then make adjustments in the height of the seawall later. Those kind of flexible approaches where we iterate and do both adaptation and mitigation are shown in the green here, and you can see how, just in a schematic, the risk stays below a certain tolerable societal threshold, whatever that is, shown in the blue. So we have to do mitigation and adaptation. There are a lot of strategies that the city has considered. Part of it is vulnerability assessment, climate risks, but also developing implementation plans, monitoring and reassessing as some of the other components. I think in the interest of time, I'm going to skip through some of these details about the structure of the New York City panel, but I think hopefully we can share these slides, and happy to take questions in the future too, in an offline kind of way. Just to highlight here that there's a role again for all aspects of society in this kind of resilience planning. Okay, and now a very quick pivot to some things at the state level, because it's so inspiring what we're seeing in terms of aspirational at this point, greenhouse gas emissions reductions targets. Listed here as the most ambitious of any major economy. So you see the 40% by 2030, 85% by 2050, and very tangible ways proposed to do it, going to 70% renewable by 2030 and being zero carbon by 2040. See also here that these plans specifically talk about issues of environmental justice, disadvantaged communities, and just transitions, making sure that there are jobs, especially in vulnerable communities, making sure that co-costs associated with new facilities, any sort of downside, isn't primarily in communities that have suffered in the past, for example, are some of the dimensions of that. And just to show some of the very specific tangible goals, we don't have time to talk about them, but there are specific plans here to develop, for example, offshore wind with estimates of how many people could receive power from these sources, how many jobs could be created. Large-scale renewables across the state, distribution and energy storage, that's a key piece, right? Sun and wind aren't available everywhere all the time, so we need to find a way to change transmission, distribution, and storage too. Major things that can be done in the way of energy efficiency. You start to see some of the opportunities that are there, the sort of positive narrative that we can turn this around and create a lot of jobs and better air quality along the way. electrification within buildings, things like heat pumps. There's so much that can be done. Going to electric vehicles quickly. All these things are being planned for, and there's major aspects of the workforce development too. So I think I want to make sure we have time for questions. So I want to just, in the last couple minutes, circle back and highlight some of the points I've tried to sort of make around the environmental justice and COVID-19, but sort of put them everywhere here on a slide. So first, this question of what are some of the connections between climate change and environmental justice issues. So I think one of the first things we have to ask is, who has been responsible for historical emissions of greenhouse gases? If we look at this problem I've been describing, it's been the United States, it's been Europe, and increasingly a few other countries, but carbon dioxide lasts in the atmosphere for over 100 years. So when we look and see so much of the developing world is going to be experiencing that high heat and humidity. We look at the major cities and delta regions, South Asia, Southeast Asia. They're going to be suffering a lot of the worst impacts, and historically haven't been responsible for as much greenhouse gas emissions, and arguably, through one definition at least, you could reasonably say, haven't benefited. We could have a philosophical question about whether the West has truly benefited from all the fossil fuel emissions, but in a certain sense they have in terms of GDP. So there's all sorts of ethical issues in that regard. Who's benefited and who hasn't. More directly, exposure to climate hazards. Not all communities experience the same temperatures, right? Who experiences the urban heat island? Which communities tend to have less shade, tend to literally get hotter during our heat waves? Often it's vulnerable communities, people with fewer economic resources, property values might be lower. So we need to acknowledge that direct link between environmental justice and hazards like heat waves. Who's living in floodplains, often vulnerable communities, impoverished communities. But it's not just the exposure to the climate hazards, it's also what we call a compounding hazard. So think about something like air pollution. Which communities are living near high PM 2.5 concentrations, these small particles that get so deep into the lungs and even into the bloodstream. We know that if you're experiencing high temperatures and poor air quality, you're going to suffer more than just the additive effects of each of those. Who has pre-existing health conditions? Who is more likely to experience stress, honestly? I think there's a growing body of research recognizing that just the stress of many minority communities endure is a baseline stressor that adds to some of these hazards and makes it harder to be resilient in the face of some of these threats. Who has access to healthcare? Who has access to air conditioning? Even if you have access, is it affordable? All these things interact in some ways complicated, in some ways very straightforward and obvious ways to increase vulnerability and risk. Who's most dependent on public transportation that could be out after extreme events? Who's less able to take time off from work, less able to work from home? Again, it's often going to be the vulnerable communities that are disproportionately affected here. And we've seen some parallels for sure with COVID-19 here, but certainly stories coming out of Sandy talk about this as well, how certain communities just weren't able to recover, in part due to the lack of resilience in some of these resources. Who do a lot of traditional institutions tend to support? Who has the broader social networks? Who's able to get access to funding, capital, or maybe has more savings? All these things that are critical to determining outcomes after a major event, whether it's Hurricane Katrina, you name it, whether it's COVID-19. And as we're thinking about our mitigation, greenhouse gas emissions reduction, and adaptation strategies, it's critical that we have this environmental justice lens too. Who's deciding what the best strategies are going to be? Are they the best, the best for who? If we're going to build a seawall, does it get built in a way that protects everyone, or does it get built in a way that just protects certain communities? There's, tons of environmental justice implications as we think about how we can respond to these climate hazards, and we have to make sure all communities are included to ensure that that's done in a just way. And then, some related points here, but I wanted to reflect a little bit on things that we've learned during COVID-19 about interactions with climate. This is something I've been asked a lot the last few months. One thing we've, observed very clearly is during the lockdown and during the economic contraction, certain types of emissions have gone down a lot. Those small particles I mentioned, ozone, dropped in some cities by 50%, at least over short periods of time. There were major improvements in air quality, people's ability to see with pollution so much lower. Very good things. You don't want it to happen, though, obviously, during a pandemic and during an economic collapse. That's not the way we want to achieve these things. Unfortunately, carbon dioxide concentrations kept going up. Emissions are expected to drop something on the order of 5% probably this year, maybe a bit more. But because carbon lasts in the atmosphere so long, concentrations continue to go up. So we need to find another way, right, to reduce emissions. And I hope we're sort of showing that pathway now, that we can get economic gain, we can decarbonize, we can, through energy efficiency and equity considerations, get those emissions reductions without seeing economic collapse. How has COVID-19 changed vulnerability to climate extremes, right? So who's sick right now? Who's recovering? How is that going to affect their ability to deal with heat waves, smoke from fires, which always kill people, right? Who's exhausted their financial resources because of COVID-19? And as we think about the resilience strategies, things like cooling centers or places out west where people can go when there's a fire event to breathe non-smoky air with like good filters, can you still use those during times of social distancing is a big challenge. And I do think, as I said earlier, COVID-19 has helped us think about and visualize cascading impacts. It can sound really abstract to say, well, climate change will do this, which will do this, which will do this. Pretty soon it's like not tangible enough for it to feel like a real risk. But I think COVID-19 makes a lot of these connections a lot clearer, right? It's not just the health dimensions that are causing people to suffer. We're seeing all these knockdown effects, and it's exactly the same with climate and extreme weather events. What climate relevant behaviors and norms aren't going to go back to normal after COVID-19? Is there going to be less getting on airplanes? Are people like me, climate scientists, going to go to fewer conferences? Are we learning that, virtual conferences, work okay? Are people going to not be, it's going to be more acceptable to work from home for a day or two a week? Those are the kind of things that could potentially lead to big shifts. And we sort of think about broader, implications for the economy and real estate of that as well. But then the big mover, I think, which is still very unclear how this is going to play out, but what are the long-term policy signals going to be post-COVID? Are we going to see, as we see more economic contraction, bailouts for and sort of decrease in regulation for major fossil fuel emitters? Are we going to see less pressure on companies to disclose their vulnerability also to things like sea level rise? Or are some of those industries going to be increasingly perceived as sort of fading anyway? And are we actually going to see an acceleration of this transition towards a renewable future and a world where everybody from investors to young people deciding what they want their next job to be or what college they want to go to, just basically insisting that the companies are reducing emissions and thinking about their vulnerabilities to climate change and reducing those vulnerabilities across their supply chains, for example. I don't know the answer to that one, but that last one is the way that we could see big change in some of these emissions trajectories. And then just to close, going back to the sort of technical takeaways. Extreme events have already changed a lot. Somebody tells you we've only had 1 degree of warming, just less than a foot of sea level rise. Hopefully I've shown that that's already hugely impactful. And we're looking towards increases in those changes. And there are limits to our ability to predict exactly what's going to happen. If we turn up the dial too high on greenhouse gas emissions and we warm things too much, all bets are off. inherently start to lose the ability to predict, and that's more likely to cause harm than good. That's a tipping point we don't want to cross. But if we reduce emissions dramatically, if we can sort of buy ourselves some time, there is, I'm totally convinced, a pathway where we tip radically towards rapid emissions reductions, big uptake of adaptation because it makes business sense, for example, because first movers will see huge opportunities. And I think what we've been missing more than anything else, arguably, is a positive narrative. You know, we've heard so much about it's going to take these sacrifices, there are going to be these trade-offs, but the truth is we're not just reducing risks. We're also, you know, have an opportunity to build actively a much better future. And I think that's another place where all you students listening on this call hopefully can see a pathway through your passion, through your interest, to contribute to that discussion, because it's, you know, your generation unfairly, talk about another justice issue, unfairly this is falling on you, even though you haven't been the emitters. But there's a huge opportunity here for you as well, and my generation needs to help support. So I'll leave it there. Thank you.
Great, Radley, thank you very much. And we're having a difficult Zoom day in that Debbie Chang, who's going to moderate, got just kicked out of the Zoom.
I'm back.
But she's back. Okay, here we go. So
okay. Thank you so much, Radley, and apologies for technical problems. So we have a lot of questions in the chat, so I'm gonna try to summarize some of them and capture a few in the remaining time that we have. So one question has to do with reining in the fossil fuel industry. How do we rein in the fossil fuel industry, especially since, can you hear me?
Yes.
Hello?
Yeah.
Okay. So how do we rein in the fossil fuel industry, especially since fossil fuel lobbyists have been so effective at influencing policy decisions? So there was someone in the chat says there was a Carbon Majors report from 2017 stating that just 100 companies are responsible for 71% of global emissions. So in terms of environmental justice, will there be a need for more lawsuits or massive pressure on companies that go further than a carbon tax?
Yeah, I think it's going to be all of the above. I think we're bound to see more lawsuits. I think also, maybe it's just a matter of time before we do see more leadership at the national level on these issues. I think we're going to see cities increasingly demanding. I think we're going to see more on the procurement side, much more demands on these issues. So I think it's all the above. And I do think there's absolutely a role for consumers, investor groups. You know, when you start to see groups like BlackRock talking more and more about these issues, you know, I think those could be critical too. And I do want to note that, you know, there are other ways to view this. I mean, the fossil fuel emitters are clearly, you know, it's a relatively small entity, as you noted, that are responsible for a lot of the historical emissions. Clearly for decades now, many of those entities have been aware of the risks. Also, we should think about some ways additionally to think about more consumption-based indicators too, and some of the products that we all consume, because you know, there could be ways to also impose some additional pricing incentives in ways that reduce some of the very fossil fuel heavy consumption too.
Great, thank you. Then there are a bunch of questions that focus on what we can do to better communicate with people, especially ordinary people who either deny that climate change is anthropogenic, or that may not see it as a critical topic, and that they should vote for elected officials that sort of support these things. So what can we do to inform people of the potential impacts of climate change? Specifically, what can be done in New York and the US to engage communities with experts?
Yeah, so I think, you know, the first thing is you gotta kind of meet people where they are, sort of not go in. Ideally, you have some setting where you can have a workshop, have an engaged long-term dialogue, and get to know people. I know that sounds challenging, but I think that's really critically important to having success. You have to, frankly, sort of tailor your points towards the audience. Climate change is going to touch everybody, but for certain audiences, you don't want to go in there at the beginning talking about polar bears. You want to be talking maybe about the military, how that's being affected by climate change, or how young people's health is being affected by climate change, or how fisheries and tourism, you name it. So tailoring the message to the particular concerns of the community. And you don't always, have to focus on climate change in the future. I tried to, show some examples in this talk of how we're already observing some of these changes. Yes, they're mostly due to human activities, but you don't need a dramatic scenario for the future. You don't need a worst case scenario to see that we're all vulnerable. We're vulnerable right now. Even if climate change somehow weren't real, there's so much more we need to do anyway in terms of resilience, given how many vulnerable people we have to the current climate. So those are some of the ways. I think another critical piece, and this gets to the idea of engaging everybody, like at our managed retreat conference, some of the most well-attended and exciting sessions were about things like, how do people emotionally come to terms with the idea of having to retreat from an area? How do you say goodbye to the land? How do you visualize, going to another place? So we had, sessions where we had actors sort of workshopping these community discussions around managed retreat. We had filmmakers talking about how they can communicate some of these issues. So like working with artists, just basically engaging the whole person I think is a critical piece.
Well, just to push you on that a little bit further, I think we've seen from the pandemic that there are huge, deep divisions in this country. Even something as mundane as wearing a mask has proven to be so divisive. So how do you think, we already know that climate change is a divisive issue. So how do you think we can tackle that? And what does the upcoming election, how does that take us in different directions? If Trump wins, what can we do to sort of combat the rollbacks, the environmental rollbacks that he's already implemented?
Yeah, that's a great question. I don't, have enough expertise in the policy arena to give, as good an answer as some folks on the call probably could. But I think, it's important to note that with all the rollbacks and all the sort of delays of the last 4 years, even in that environment, there has been a narrative of cities uniting and pushing further, states, companies, investor groups, for example. And look at what we've seen, I think just in the last decade, coal use in the US has gone from being 50% roughly of our electric generation down to 20. That's, part of the Obama years, but that's happened in the last 10 years, and it hasn't decreased in the last 4 years or so. So your point is right. We more would need to happen, but just to sort of make the point that even under those adverse circumstances, I think you can make the case that we're building towards the tipping point. But engagement, I think, with the private sector and at the community level, getting voters to know more about these issues and their vulnerabilities and the opportunities are critical things too.
Great, thank you. What is there anything that we have learned from the pandemic? Any changes that we can continue to build on? Do you think that there is hope for systematic environmental and social change once we eventually come out of this, or is it kind of going to return to business as usual?
Yeah, I don't think it's going to return to business as usual. I don't think, I think it's, it's somewhere in between. I think we'll see, people feeling like maybe they don't need to fly as much, don't need to drive quite as much, but we'll probably go most of the way back to where we were. I don't think we should, think that COVID-19 is going to, be totally transformational in that regard. But I do think after a disaster, whether it's a climate event or COVID-19, which is, primarily is not that kind of climate event, people are more aware of vulnerability. There's a tendency to sort of forget a few years after an event, but now that people are sort of aware that we're all connected and that we do have these really vulnerable communities, that's sort of the time, I think, to try to push forward with momentum to get larger change. But I don't think COVID-19 in itself, when it recedes and when the economy starts to get stronger, would put us on a completely different trajectory. I think there'd be a lot of sort of sloughing back.
Mm-hmm. Yeah. Focusing back to New York, there have been plans to devise a system of barriers that wrap around lower Manhattan from the east side to the west side and around the tip of Manhattan, known as the Big U. Yeah. And there's been a lot of controversy over these projects. So one comment in the chat is that everything you were speaking of related to environmental justice speaks badly of New York's ESCR project that will destroy the entirety of East River Park, supposedly to secure flood protection. So I wonder if you can talk about both sort of the environmental justice angle of projects like that, as well as the bureaucracy and red tape, because that project has been delayed for a couple years now. And so I wonder if you could speak to those issues.
Yeah, I mean, I wish I knew more about the specifics of it. But I can speak to, I guess, what some of the criteria to think about are. I think so. One issue which I did sort of allude to is which areas are getting protected. Where are the primary investments in the large barriers going to go? For example, obviously has huge environmental justice implications. My understanding, and again, I don't know enough about it, was that some of these designs actually do endeavor to increase the amount of green space and parks. So I'm not sure I don't know, others would know more. I'm not sure they have to be a net negative from a sort of access to parks perspective, but with the caveat that there are real concerns, I would say, from the perspective of when you do certain types of large infrastructure projects, you certainly have to make sure you're also considering things like sediment flow, erosion, how it's going to impact ecological flows. So I don't know enough about that project to say whether that's being fully accounted for, but in some, abstract configurations in some cities of what a barrier could look like, doesn't necessarily, ensure that those kind of concerns will be met.
And one last question related to New York. So you talked a little bit about the CLCPA and how it has earmarked some money for environmental justice organizations. However, there's a question here in the chat that the CLCPA is celebrated for protecting disadvantaged communities, but only 35% of overall benefits of CLCPA programs are required for these communities, when almost 50% of New York State is considered lower middle income, and the current New York State budget does not include a specific amount for disadvantaged communities required per the CLCPA. So I wonder if you can talk a little bit more about a just distribution of funds, given some of the constraints imposed by the state budget and the fact that some community-based environmental justice organizations are not well represented and not able to get some of these funds.
Yeah, I'm glad we got that question, because I think it illuminated for the group, more nuance than I'm aware of. I'm also glad you mentioned the fiscal situation, because that's it's sort of related to that fifth point I had in the links between COVID and climate. But we have to acknowledge the looming fiscal crises, probably at city and state levels, due to indirect effects of COVID-19. So what is that going to mean for some of these plans? Is that going to lead to upping the ambition or decreasing it? I don't know enough about the specifics. I apologize to speak to that 35%. But anecdotally, just to sort of highlight that, we've seen across all of New York State how disproportional some of the vulnerability is, right? Even if something like Hurricane Irene the year before, Sandy, the rainfall that struck some communities in the center of New York State, roughly. If you looked at the sort of official economic damages, captured by GDP or asset values, they might not have looked that huge, but for some of those communities that had, one bridge into town that got cut off, it's really devastating impacts. So, there's also that dimension, which includes in the New York State case, a sort of rural urban component as well, in addition to some of the environmental justice issues within urban areas. I apologize for not being able to speak more deeply on that question, but it's critically important.
Now, I think we're challenging you with questions from all sorts of different angles. We're expecting you to answer all of our, not just New York related questions, but all the climate questions that we have. So thank you for your conversation.
Radley, thank you. I just want to add my thanks to you for sharing your remarks and your expertise and for this conversation. I want to thank everybody who joined us. I want to thank Debbie, who organized this and helps to lead the Climate Policy Fellows. I want to congratulate the Climate Policy Fellows yet again. And I hope this will be not the last time we get to meet with Radley, and the fellows in particular, I know, are looking forward to having some time with him. For them, it's just the beginning, and for us, it's a continuation, and we will have many more, I hope, conversations about these important issues as time goes on at the Colin Powell School. And as we close, I want to thank Turner Construction, again, for having made this possible and for their support of the Climate Policy Fellows program. And I want to just mention, we have one more event. The Supreme Court, I think, finished its term, I think this morning, maybe, finally with its final decisions. And a week from today, we will have an event looking at some of the important decisions that they have issued in just the last few weeks, particularly the ones relating to the provision of rights. And we'll have a conversation next Thursday at 12:30 about the LGBT protections that have extended into the workplace, about the DACA decision, and about the reproductive rights decision. And I hope you can join us. We'll send some details. We've also taped this conversation, so if you had the same sorts of Zoom troubles that we had, it will be posted online, and we'll send the link out so everybody can have it, and you should feel free to share it with your friends. With that, Radley, thank you again. Thanks everybody for being with us.
Thank you.
Have a good afternoon. Take care.
Thanks. Bye.
Bye-bye.